till it's 9 o'clock on the dot from my own side before we could start. And I believe we are all ready to be here today. Okay, so as usual, before we start, I always love to give shout out to those that came very early. And of course, the first person I met here today was Thomas Oselu. In fact, he was even waiting at the gate from me to open the door for him. So Thomas, I welcome you to the meet, and the rest of us who joined us very early too. So thank you everybody for being here.
Thank you, David.
Okay.
Simple share. I'm waiting for that tax 0 and tax 1 so that I can actually get something.
Okay. There's no problem on that. There's no problem. All right, great. Remember we discussed yesterday about how the structure of all these things is going to be. And please, I want to apologize to us about yesterday. We're supposed to have someone come speak with us, and this morning I was able to speak with him, and he said he misplaced his phone in a taxi on his way home. So that was why when I called him, he was not able to pick because he wasn't with his phone. As a matter of fact, I was able to reach him. He messaged me on LinkedIn that at least I should apologize to everybody that he misplaced his phone in the taxi. That was why he was unable to join us. So please, on behalf of him, I apologize for what happened yesterday. It wasn't really his fault. Please. Okay. So let's go into the business of what we have today. So as we already know, for those in cohort 11, we are on our task, on our project, Simple Shell. Though it's not simple, you can call it a difficult shell. Okay, so yesterday we agreed that I'm going to be sharing out the tasks to some of us present. And we all know the benefits of doing that. In the process of you presenting, you get to do more research and learn more. And also when we ask some questions, you get to understand even more things you didn't read about. So that's one of the benefits of you being the presenter. Okay, so today I assigned tags 1 and 2. Actually, he messaged me like now that he'll be joining us a bit late, though not very late, that he's on his way home. Okay, but he's one who's going to take, will soon be home. Okay, he's one who's supposed to take us on tags 0, 1, and 2. Okay, then definitely I will assign tags 3, 4 to another person, then 5, 6 another person. That's how we'll be doing it. Or I could just give out only one tag to you, depending on your strength and your willingness to actually present. Please, when I call on you to take a particular task, please be open-minded and accept it. You don't need to know it. As I said yesterday, you don't need to know it. Like me, if you give me any of them, I don't need to know it. I'll just accept it and go and do my research. And I come and present to you the one I can present, and the rest of it, I'll let you teach me. Yeah, that's the essence of presenting. It's not to be good, but to learn more. Okay, so since Bright is not here, we could just go over tax 0. Yeah, we should already know how to attempt all those tasks, but let's just attempt tax 0. So everybody, please open up to your shell project. I'm opening up to mine now. Okay, but before we start, since the person who's supposed to take tax 0 or tax 1 and 2 is not yet here, before we start, please, does anybody have anything to say before we start? Does anybody have anything to say before we start? You might want to be. And then we can move on then. Okay, for those who just joined, I said I'm assigning the tasks as we agreed yesterday to some of us. So please, when I call on you to take a particular task, please don't say you cannot. Rather, be open-minded and accept it. Okay, that is how we are all going to learn. And today it is Bright in Yabasi to actually take us. Although he's not here yet, he just messaged me like 2 minutes ago that he's close to the house. So once he gets to the house, he's going to join us, and then he'll take us on tags 1 and 2. Okay? So, but let's just go over tags 0 while he's coming to join us. So everybody open to your simple shell. So you'll be following along. Yeah, like me, I just got to the house now. It has not really been easy. As a matter of fact, I had to spray my house. I'm sitting down outside now for the whole thing. Okay, so I'm trying to open up my compiler. I'm using the online compiler. I'll share my screen in a minute, but everybody open to your shell project, please. Okay. Okay. So I'm sharing my screen now. Okay. Okay, I'm trying to share my screen, please. Hang on. See, I have a new page. Okay. So Pascal, so can you see my screen?
Yes, I can see your screen. I can see your screen.
Okay, good. All right. Okay. So as I said, tasks 1 and 2 was assigned to Bright Iniabasi. He will join us in a minute. Okay, just give him time for him to settle down and he will join us. So tax 3 and 4 or tax 3, I will assign it to another person before the end of the session or after the end of the session. Okay. So when it comes, I don't want to start saying anything about any of the tasks so that it will not oppose what you have in mind to come and tell us, please. So let's just discuss on Betty will be proud. Betty is not going to be proud of anything here. Okay, so this task says we should write a beautiful code that passes the Betty checks. Okay, which means we should just write a random code and follow the Betty standard. And for those of us who have not read about this Betty standard, you can ask for the link, and then I will send you a link to a documentation on Betty standard, so you could also know how you could actually write codes that will pass the Betty standard. Okay, but now let's just write any random code that will pass Betty standard. Okay, so I'll go to my online compiler. Okay, let's close it. Remember yesterday I said somebody's hand is up. Okay, remember yesterday I said you could write anything. Like for me, I'm going to just write my own program, what I have in mind. Okay, so now, so let me point out this, that this program I'm writing here, this is an online compiler, not a compiler where I have a storage on my system. So if not, we would have defined our header file, our function inside of another header file and name it main.h. But in this case, it could be shell.h, whatever it is you want to name it. And then I will include it in my program. Please take note of that. So when you're writing your program, like your shell program and the first task, it might not have this stdio.h as the case may be. It may have if you are going to use the printf function. But if you're not using printf function, it may not have this. You may have to include your shell.h file or your main.h file. Please, let me mute your mics, please. Somebody's mic is on. Okay. So please, let's also take note of that. Except you're using the printf or any of those functions that are present in this, then you can use this. But if otherwise. Like for me now, the function I'm going to be using, the header file I'm going to include, it might be shell.h. Now, your own must not be shell.h. Your own could be another thing. This is shell.h because that's what I'm going to name mine, and then I declare my function inside of it. So that's a lot. Okay. So in my program, I'm just going to say, I'm just going to write a function that adds two numbers. Remember, I said this yesterday, that's what I want to write as far as it passes Betty standard. So, of course, we already know we're going to give it our comments. Now, regularly, you could write your comments like this, right? Hit enter, and then whatever you are writing goes in between this. But I'm still trying to understand why they said we should, that Betty said we should add another star here, okay? And then for each of these lines, we have stars, or asterisks, as you may call it. But it is just a standard, so you follow it. Okay? Let's go back to now. Okay, so here I could say add. I'm writing a program that adds two numbers together. Add two integers. Definitely two integers. And then you can even put a star here. Since you could do this for yourself too, and it will work for you. Then I'll say at num1, the first integer to be added. Remember, there's no regular pattern to doing this. This is all how you see it or how you want it to be. And then I'm going to have num2. I would say the second integer to be added. Okay? And then I go over and say return. And I'm going to say the results, definitely. That's going to be the result of the addition rather. Please, if writing about it comes into the meet, someone should inform me. Okay, so basically these are my comments. This is num1, not num11. If you see anything, just inform me. This is num1. Okay, then I'll go over to declaring my function, and my function is going to be, of course, add, since I'm adding two numbers. And then I'll say the first number as I declared there, or as I mentioned, there was num1. The second number is going to be num2. Right, we already know how to do all of this. We've studied them in our function classes, right? So I'm going to return, the reason I'm putting int is because I want to return the result, yeah? So I'm going, which means I'm returning a value, and in this case, I'm returning an int. So that's why I'm having a data type there. So I'll say num2, right? I could include this in brackets or parentheses, as case may be. Remember, I'm following standard. And that is that. I've written my function. I've written my program. Rather. So I could just clean all of this. I could clean this. I could clean this and submit my code like this, and it works. Yeah. So I could also remove this, since I'm not going to use any printf or any of those functions inside of SCB. I could remove this. So basically, this is how my own looks like. Okay, now I'm going to go over this again. Shell.h means this is my header file. So I might have declared, or I might have declared this inside of my header file, like a prototype of this instead of my header file. Okay, so that's why I'm including shell.h header file here. I hope that is clear. So basically, this should work for tax 0, or you could want to write a longer program. It will still work as long as you are following the Betty standard. So I believe that is clear enough. Okay, Justice Obasi, your hand is up. Please go on.
I just wanted to call your attention to a small error in your code. on the
Okay.
return inside the function, it should be num1, not just num.
Okay. Thank you very much. If this was actually an ALX star, this is how I'll be having error, and I will not know what was it was. Okay. And thank you very much, Justice. Okay. So that should work for our tax 1. So please you permit me to reach out to Brighton Yabasi. Remember, we are sharing all the tax. I don't want to go into tax 1 now, and then when he comes, he's going to conflict what he has in mind. So let me just text him. But while I am texting him, the names I'm going to call out now should prepare to take us for tomorrow. Okay, so someone's mic is on. Dukesen, please. Dukesen here. Dukesen, please. Tomorrow you are taking tax 3 and 4. Are you there, Dukesen?
Yes. Sir David, I complained about something about my laptop.
Okay, that's right.
Proper. Yes.
Okay, that's true. Okay, but can you give us like an explanation of how we could go about it in text? Then you could come to explain to us while I give them your notes.
Okay, that will be tomorrow, Abi. For tomorrow.
Yeah, tomorrow. I will love it to us. Yes, for tomorrow. 3 and 4,
Okay.
yes.
Okay, no problem. I'll try my best.
Okay, would you want an I see. Okay, so what will happen? Okay, I'm assigning it to your group. So you and your group could do something about it, and then somebody from your group could actually present it. You could coach the person on how to do it, and your group is going to take the score for it.
Okay, no problem.
Okay, so please, I look forward to that, and this is going to also benefit them, not only us. Okay, so I appreciate you for that, for wanting to do it. Thank you. Okay, so Iberi Demian, if you are there, please, you'll be taking tax. That was tax 3 and 4. You'll be taking tax 5. Iberi Demian, please, you can unmute your mic and say something. You'll be taking tax 5.
All right. Thank you. No problem. I'll try my best also. Can you hear me, please?
Okay, thank you very much. So, yes, I can hear you. So your tax 5 is going to be on tomorrow is Thursday, on Friday. But tomorrow is Wednesday.
Before then, I had something to. Tomorrow is Thursday.
Okay, it's going to be on Friday.
Yeah. Okay. No problem. Because I had something to say before then. I don't know if I can say that.
Okay, go on.
Okay, if actually tax 0, it's just to write a program that passes the check. Why do we need to write it? Because, for instance, when you push your code, if you do a project, we have tax in projects. Let's say you have 10 tax, and then you do the 10 tax at the same time, and then push everything at the same time, and then commit. All the 10 tax should check as long as they're correct. So if you do tax 1, skipping that tax 0, of course, it's going to pass petty check before it's approved for tax 1. That should at least satisfy the tax 0. Is that right?
No. Tax
Why?
0 is on it. Tax 0 on it is on its own. Remember how our project or each of our everyday tax are. Each of the tax are on their own. That's why you're having this below each tax. So for each of the tax, you get a score for it. So if you don't pass this, if you don't do this particular one, of course, you will get your scores for others, but you will not get your score for tax. Let
me re-explain. Yeah, let me re-explain that. Now, you are saying that because if you look at other projects, other tax we've been working on, we have 3 basic things. The first thing is the GitHub repository, the second is the directory, which you create, and then the third one is the file. So it checks your code in respect to the files of each of the tasks. Now, looking at this present work we are to do, it's only GitHub directory, which means that everything you are doing falls under one parameter, under one directory called shell or simple shell. So it's not deciphered into different files. It sees the code as one particular entity. So far, it portrays what you're supposed to do for that very project. So now, if you write tax 1, before you pass that tax 1, it simply means that you've passed the check, depending on what they want to do, like creating the command that will allow you to write your simple shell. So if that passed the check, it simply means that you've done something for tax 0, since it's open for you to do anything. So why do we need to write any other code, since number 1 will allocate the same value to tax 0?
Okay, I think I
I
understand
get what I'm saying.
Yes, I understand
Okay.
what you're saying now. Okay, you are saying that, okay, since we don't have a particular names for each of these, so whatever we do in here, we are going to actually pass the standard for 1 here. So basically, you could
Yes.
also look for that and pass this one too, right? Okay.
Yes,
Okay.
yes.
It could also work, but then you know how ALX is, you know how they are. So you could actually try that. If you miss it, then you know that you've missed it, and then you can write another one. But it could also work. Okay, I get what you're actually saying. But it's better to be on the safe side and just write your program and put there. Yeah, but it might work. It might work. Yes. It might work. Okay, so I was still okay. Dixon, okay, please go on.
Okay. Sorry, for this print, for this simple shell,
Yes.
I will advise that you do your pushing for each task. The reason why I'm saying this is because if you go through the outline that was given, after that first task, you were given another one. After that one, you were given another one. See, let me explain like this. It's better you do a task at a time, not completing your full task. Because if you complete your full task and you do your check, some will not work. The reason is because, for instance, there was one of the tasks, I think it's task 2 or 3, that said print out the arguments passed to the variable. Just print them out. They are not executing. So now, when you run the code, once you type any command within that listen, your get line gets everything and print it out. Then after that one, it will now tell you to do the next one, execution of a command. If the command is not found, it will tell you command not found. So now, if you have written all your codes and pushed everything once, if you're checking for that task that said just print out the line without executing, you will have issues.
Mm-hmm.
There was somebody I was watching. He did the same thing. So what he now had to do was to start dividing his code, do for a particular task, push that one, check. When that one checks, then go and complete that code, then push and check. But if you push everything once, that means you've finished everything. When it comes to running a particular code that does not require execution and your code is already executing, you have issues because it will not be the same with whatever output that should be given. I don't know if so. You should not rush with your pushing. You should not push everything once. You push for one task. When you finish that task, then push for the next task and check your task. That's how you progress with this particular. I don't know, but you can try pushing everything. You'll find out that your checker will give you errors.
Okay, listen, I appreciate you for that. But anybody who pushes all the tasks at once, I mean, how did you do it? How did you get to do everything and push it at once? Definitely, it's going to be one after the other. But then, he's actually saying something. So please, that's why I said, let's not go and copy everything. Let's try to do some by ourselves. Okay, so please, our time is going. Let's actually start. Bright in Abbas is already with us. Remember, it's one taking task 1 and 2. Okay, so we're about to start, but okay, that person's time is down. So please, if you have any questions, just keep them. Okay, when it's time, you can ask your question. But for now, let's just try to achieve what we came here for today. So please, I have assigned someone who will take tomorrow, which is Dixon. Dixon will take us on 3 and 4. And then, who did I give tax 5 again? Hold on. Okay, Iberi Demian, please, you're taking tax 5. take note of that. And then Richard is going to be explaining the get line function. Yes, Richard, please take note of that. Okay, so I'll give you time to do that. Okay, so Bright Inebasi is already here with us. He's the one who is going to take us on tax 1 and 2. Okay, so we already know Bright Inebasi. He's one of us. He has been here all the time. He's a great guy. So Bright, please unmute your mic and let's start, and welcome to the meet.
Okay, hello everyone, good evening. Can you hear me?
Yes,
we can hear you.
I can hear you.
Yeah, good evening everyone. First of all, let me start by apologizing. I'm very, very sorry for joining in late. I left the meeting. I was in the meeting, and so we closed late, so I just arrived home like some minutes ago. So please, I'm very sorry for taking some time. Can we proceed?
Yes, of course we can. Please share your screen.
All right, let me share my screen. Let me know if you can see my screen.
We can see your screen, yes, but please, it's like you help us speak. Okay, yes.
You can see it, right?
Yes, we can.
All right. So, first of all, let me say thank you, David, for the opportunity to present tasks 1 and 2. So, what I'll be doing basically is to present the logic that I came up with to use to solve task 1 and 2. And as we know, there are different logic, there are different methods, people can use to solve this task. So I'm just presenting my logic, and it's for us to rub minds together, and then we can even improve on it too. There might be even better logic than this. So so the simple shell project is basically to replicate, the function of the shell. The shell that we all know. The shell, what it does basically is to take in input from user, to prompt the user for an input. It takes in that input, that command, interprets that input, and then it displays the result if the result needs to be displayed. So I don't know if task 0 was discussed yesterday. So for task 1, so what I did was, first of all, to go to the concept page to read about all those things. That helped me to gain understanding of how to approach the project. So for task 1, it says here that we have to display a prompt and wait for the user to type a command. The command line always ends with a new line, right? So the prompt is displayed again each time a command has been executed. So we know the way the shell works. It's when you write a command and then you press enter, the shell executes that command, and then the next line again comes with another prompt. For example, if I put echo, all right, I want to echo hello world.
I need to focus.
So you can see that it prints out hello world, and then this prompt comes again. So which means that this prompt is going to be, it's going to keep coming on as long as as long as this terminal is open. You get? So which means that there is going to be an infinite loop. All right. So let me open my. All right. So the first thing I did was to first create some basic files that I'm going to use. So I created my header file to keep all those function declarations. Then I created my shell.c. This is where I want my program to start from. This is where my main function is going to be in. All right. So now, back to the question. It says that to display a prompt and wait for the user to type a command, meaning that I'm going to display a prompt on the screen. and then I'm also going to receive command from the user. All right. So, hello, can you hear me? Are we together?
Yeah, yeah.
Yes.
Yes.
All right. So, let me include my header file. That is shell.h, and then so this will be my main function. All right. Now, remember we are getting command from the terminal. All right. So all those parameters, the argument count, argument vector, and then for this project too, we are going to use the environment variable. All right. But for now, we are going to focus on the ones for this task. All right. So for this task, I'll start by using the argument count, the argument vector. So this argument vector, this is where I'm going to get the command from, right? The command from the terminal, and then the environment variable. Let me call it env. All right. Now, so the way I did it was, I said if the argument count, if the number of arguments on the terminal is equal to 1. So what I want you to do, I want you to, execute the command. All right. I want you to execute the command, meaning that, for example, now this one now, after running this, here is it. After compiling all my files, and then I run this executable. So I'm going to receive this command, this particular command from the terminal. All right. So if the argument count is 1, what I want you to do, I give my own the name prompt. All right. And in that prompt, the prompt is going to take in the argument vector and the environment variable. So the environment variable is going to be used later on. But for this task now, we are going to make use of only the argument vector. You get? So so I have to create the function for this one to execute this prompt. So let me just create it here. All right. Then I have to include my header file. H. All right. So and I did I made mine void. Then remember, from here I'm taking these two variables, so I can just replicate them here. Argument vector and then the environment variable. All right. Then let me also add it to the other file. So let me do this. Mine is shell h. So if it's not defined, then it should be defined. Then I'll end it with end if. Alright, so that's the declaration for that function. So now I've taken in this argument vector and then the environment variable. So now in this prompt, right now the tag says to display a prompt and then wait for the user to type a command. So the first thing I'm to do now is, and again remember I mentioned that the after a command is executed, the prompt has to appear again, meaning that the loop for the appearing of that prompt is going to be infinite, right? So I'll use the while loop for that. While 1. So if it's 1, it's going to always is going to always be true. So it is that makes it an infinite loop. All right, then. So now I'm going to print the prompt. Okay. So to print, I have to include the header file for that. That will be standard IO. Include my standard IO header file that I can print. All right. So, and I'm to print. I used C is fun. C is fun, and then this space, and so now this one now we print out the prompt. All right. So after printing the prompt, I'm expecting a command from the user, meaning that if a user types a command, I'm to receive that command from the user. And the function that I used to receive that command is the getLine function. So if we man getLine and we check it, so it says here that the getLine reads an entire line from stream. All right, the stream will be our standard in. It will be what we are getting from the terminal. So it reads an entire line from the stream, storing the address of the buffer containing the text into the line pointer. All right, the buffer is not terminated and includes the new line character. Now this part is something to take note of. It includes the new line character because when I first did the program, I did not take care of this new line character, and so my program was not working as I expected it until later I realized that I was trying to pass in I passed in the new line character as part of the command that my exec v function should work on. So the getLine function, it reads an entire line from the stream, storing the address of the buffer into this line pointer, and then the buffer is not terminated, including the new line character, and it says that if the line pointer is set to null and n is set to 0 before the call, the getLine function will allocate the buffer for storing the line. This buffer should be freed by the user program, and then all that. And there was something else that was mentioned here. It says, in either case, on a successful call, the line pointer and n will be updated to reflect the buffer address and allocated size respectively. So let me try to explain that. So here I get from this file stream means whereas it's the source from which the command is coming. So and that command is coming from the standard in. Then this one now will store the size of that command, that string that I'm fetching from the terminal, and then this one stores the address. It stores the address of that string that is gotten from this place. And so one thing with the getLine function that I've realized is if normally we are going to initialize this n and this one. Now it says somewhere that if it is already initialized to, if this line pointer is already initialized to null, and then n is initialized to 0, if what we are fetching from the terminal is not, if the size of the string we are fetching is not up to what we initialized n as, the getLine function will automatically increase the size. And then update this line pointer. So what we do now is to initialize these parameters. All right. So what I did was to excuse me. So what I did was to for the first one we have a double pointer. So for me, I used string. Permit me to use string. All right, so I use string, and I initialize it to null. Then the next one is n. So I will have to dictate a variable n of type n, and then I initialize mine to 0. What again? So the last one is the file is the file stream, which we are going to get from the standard in. So then again, the return value for this getLine function, it says that on success, getLine and this other function, it returns the number of characters read, including the delimiter character, but not including the terminating null byte. This value can be used to handle blah blah blah. Then it says something important here. It says both functions return -1 on failure to read a line, including end of file condition. Now, in the question, in the tag that was given to us, we are told to handle the end of line condition and end of file condition. And the end of file condition, what it means is, just like name says, after reading when the computer is reading what you have on the terminal and it gets to the end of that string, it's going to return -1. That's if you are using getLine function to read it. So if, let's say, I type a command /bin/ls, so that is already a string. Now when the program is fetching that command and then it gets to the end of the string, it gets to the end of that string, it's going to return -1. You get? So we are going to take care of that condition here. So then remember that it says that the getLine function, it returns the number of characters read. So I'm going to declare a variable. Let me see the return type of this. The return type is signed size t. So I'm going to declare a variable to store the return value of that function. Size. What other file is this? Are we together, please? Hello?
Yes, we're together.
All right. So please, if you didn't get anything I've said so far, just let me know, please. All right. So it returns a value of this type. So I'm trying to the other file is standard IO. I think I have it already. So why is it not appearing? Let me just do it. Size C. All right. Let me call the return the name of the variable number of characters. All right. So I don't know. I'm trying to remember the header file that's installed. Let me use standard library. You know where it's giving me error.
Size.
Please. Huh?
I think it's uni std.
Uni std, right? Okay, let me try that.
The SP for the size T. It should be a single S, not double S.
No, the return type is this.
Okay.
Yeah, so you have to follow it. So let me try the uni. Okay, yeah, so that is it. So then so to get the user's command, I'll use this getLine, and then I'm taking the address, the pointer to store the it says getLine reads the entire line from the stream, storing the address of the buffer containing the text into this. So this is going to be the pointer. It's going to point to, it's going to hold the address where that string we are copying is. So, and I use mine as string, so I'll use this string. Then the size of the file is, and then the file stream is going to be standard in, because we are getting the command from the terminal. All right. Then I'm going to check. Remember, in the man file, it says that if the return type says that both functions return -1 on failure to read the line, including end of file condition. So I'm going to add a condition here. If the number of characters returned, if number of characters is equal to -1, so meaning that if what is returned is -1, it means that it's reached the end of the file. So if it reaches the end of the file, now what am I supposed to do? The man page says something here that says something about freeing the line pointer. I can't find it now, but it says something about freeing the line pointer. So if it gets to the end of the file, what am I supposed to do? I'm supposed to free that string. Remember that memory was allocated to this string. So if it reaches the end of the file, I'm to free the string, and then I'm to exit. I'm to exit this. Function. All right. So now, if what was returned, if you have not gotten to the end of the file, so what am I supposed to do next? So I've printed it. I've printed the command. I've prompted the user for input. I've stored the input I've stored the input in this string. Now remember that string, if the user is to type /bin and then /ls and then you press enter, the computer, right? The getLine function also reads that enter. That's a new line character. That enter, the enter key, gives us the new line character. So when you press enter, the new line character, the getLine function also fetches that new line character. And so we have to deal with that new line character, because if that new line character is there, the execv function won't execute the command. All right. So one way to remove the logic I used to remove mine was to find where the new line character is and then just set it to null. So what I did was, first of all, I'll need to declare a variable here, I. Then I set my I to 0. Then I said while string serve the same purpose. So while the value, right, at that particular index is not equal to null. So what should you do? Now, it will keep looping through every, each index in this string, all right, this string variable. And then if it finds any string, if it gets to an index and that index is equal to, and the value at that index is equal to the new line character, right? If it's equal to the new line character, what I want you to do is that value at that index now should be set to null. Yes, so this was what I did. So that to remove this new line character, so that I can execute the command. All right. Then so now I have my string, right? Now the next thing to do is to execute the command that the user has typed in, and the function to do that is the execv function. And from that concept page, it says here that the system call execv allows a process to execute another program. All right. Note that this system call does load the new program into the current process memory in place of the previous program. On success, execv does not return to continue the rest of the previous program. So I think there's something I'm missing. I'm supposed to create a child process before calling this function, right? If I can remember. Yeah, I think so. I'm supposed to create a process, but before that, I want to create what I did also was to create another variable to store this string, right? And that variable is an array of strings, because as we go further in the project, our function, our program is going to be executing commands with arguments. All right. Now, if you look at this exec_v function, you can see that we have here an array of strings. All right. So, and this one alone now is a command on its own. This one now, they are the arguments for this command. So, what I did was to do something like this. All right. For that task 1, I did this. Then I created the variable. I created this variable. Then I initialized it to null. When we get to task 2, is all these things that some things here are going to be adjusted, but I'm just trying to do for task 1. So I was just following what we have here. Now, there was something that the man page said about this exec_v function. It says that exec_v executes the program referred to by path name. Right, this causes the program that is currently being run by the current process to be replaced by a new program with newly initialized stack, heap, and data segment. So what this basically means is that I want to execute a command from the user, right? And so if after executing that command, remember that this prompt has to be displayed again, because normally what the exec function does is that after it executes, after it runs the program, it doesn't go back to continue the program it was run. It says it executes the program referred to by path name. This causes the program that is currently being run by the current process to be replaced. All right, no, sorry, not here. It's in the man page. It's in the concept page. It says that note that this system call does load the new program to the current process memory in place of the previous program. On success, exec_v does not return to continue the rest of the program. But for our program, we want it to we have an infinite loop here. So after the command, after our program has run a command from the user, we want it to still display this prompt. Meaning that for us to do so, we have to create another process that will handle the running of command. So that if the exec_v function leaves that process, it will come back to continue this program. You get? So the way to do that now is to use that fork. The fork command is the fork function. It is some function of system call. It creates a duplicate of this process that is currently running. All right, let me man that. So it creates a new process by duplicating the calling process. So this program that we are running currently, all right, this is already the calling process, right? And then, so this fork is going to create a new process by duplicating the calling process. This process is referred to as the child process. The calling process is referred to as the parent process. So we are going to create a child process, and that child process is going to deal with, the command. It's going to run the command that the user is going to type in. And so after the child process leaves that, after the exec function leaves that child process, our program is still going to continue running so that this prompt can still be displayed again. So what we are going to do is to create a child process, and the command, the prototype here we can see is pidt for void. All right. So what I'm going to do is to then again let me see the return description here. It says on success, the PID of the child process is returned to the parent, and 0 is returned in the child. On failure, -1 is returned in the parent. No child process is created. So the fork returns, two different PIDs, right? Not two different PIDs. It returns when it's returned, it returns the PID of that child process that is created. It returns it to the parent process, right? So it returns it to this program is said that was running before that child process was created. And then it also returns a value to the child itself, and the value it returns is 0. If the fork program if it ran successfully, right? So I'm going to create a variable to hold the return value of this fork function. And let me see the return type. So it's of this type, PIDT. So what I'll do is I'll create a variable of that type, and I'll call it child PID. That is child process ID, and that. So I'm going to do this fork. So what I've done now, this now has created the child process. All right. So now I'm going to check the return value of the child process. Now, it's either if the fork function or system call failed, it's going to return -1. So if that means what to be stored in child is -1 if that fork system call fails. So if the child PID is equal to -1, what I want it to do is let it free that string. All right. Let it free that string, and then let it exit. Let it exit. It's this. Right. Now, then, but if what was returned is what was returned is 0, meaning that this one now is taking care of what is returned to the child, right? If what is returned is 0, this is where I'm going to run that exec function. But now there's something to note about all this process, creating a process and all these things. Now, remember that this fork system call, it creates a duplicate of the parent process, meaning that this was something I discovered when I was trying out those exercises in the concept page, that the parent process and the child process, they are running together, but the parent process runs before the child process. So it's just like this now. So the program comes here, it prints this. The parent process now comes here. In the parent process now, this prompt is displayed, and then it does all of these things. And then that parent process now creates this child process. All right? It creates this child process. Now, as it creates this child process, from this point onward, after it creates this child process, from this point onward, the child process now begins to work. All right? So now, remember I said the parent process runs before the child process. So the parent process now will come and check if what was returned is -1. All right? Now, if what was returned is -1, it means it's a failure. The program failed, so it's going to do this. Now, if that is not the case, if it comes here, now the parent 0 will never be returned to the parent process. All right? 0, as you see from the man page, it says 0 is always returned to the child process, but the child's PID, the child's process ID, the child process identifier is returned to the parent, meaning that if this condition is not satisfied, it comes here. This condition cannot be satisfied for the parent process because the parent process does not receive 0. All right, the 0 always goes to the child process. So if it comes here and that's not the case, it means the parent process now has to continue doing some other things. All right. Now, what we want to do is that if the parents, we have created this child process, what we want to do is to execute a command. So we have to tell the parent process to wait first, so that child process can execute that command before the parent process can continue, going over this loop again. That is where that wait function comes in. So if it checks here, it doesn't go. this one won't. This one definitely is out of it. So we have to do else. Else, let it wait. So let it wait. Now let me see the man page for the wait. Man wait. Now it says here that all of this says a state change is considered all these system calls are used to wait for a state change in the child of the calling process. A state change meaning that something has changed in that child process, right? And obtain information about the child whose state has changed. A state change is considered to be a child terminated, the child was stopped by a signal, or the child was resumed by a signal, right? Now, remember I said that when we use that exec function in that child process, it won't continue running the program, meaning that that child process now is going to be terminated, right? It's going to be terminated. So that exec function now terminating that child process, we send a signal to this wait. We send a signal to this wait telling it that there has been a state change in that child process. So in the case of a terminated child, performing a wait allows the system to release the resources associated with the child. If a wait is not performed, then the terminated child remains in a zombie state. Right? If a wait is not performed, then the terminated child remains in a zombie state. So meaning that, when we created that child, when we use that fork system call, it duplicated the parent process. So resources that were already allocated to that parent process now are now given to that child process. So what this wait does is that when we use this wait system call, and then when we use this wait system call, after the child process has finished doing its work, the wait system call is going to release the resources that were allocated to those resources that were given to that child process for it to run whatever it needed to run. Now it says if a child has already changed state, then this calls return immediately. All right, and blah blah blah. So let's get there's something else. This status. Now, because of that, let me just go straight to the point. This status, what it does is that it stores the status of the let me just get it there. Let me not use my head. So it's a if W status is not null, wait and store the status information in the int, all right? So what the status does is just to keep track of the status of what happened in the child process. All right. So it keeps track of what has happened in that child process. So I will need to create a variable for that. So the type here is int, right? So what I did was to create a value for that. Okay, I already have int here, so I can include status here. My status here, and then let's see what is keyword. So this is going to be an address, right? Because this is a pointer. So it's telling us that it's going to hold an address. So what is going to be here is the address of status, all right? But for this task, we didn't really use status because the status, according to the man page, it says that you can now use this status to do some other things, to check for some other things. But I just did it following what was done in this concept page, so I've not really looked at what that status really does. So now the parent process runs first, and then it comes to this place. It doesn't come into this place. It doesn't even come here at all. So it comes and then it waits, right? So we have told the parent process now to wait for the child process to execute, to run its own program. So when a program gets here, the parent process waits, and then the child process now picks up from there. So the child process, remember, the child process started after this fork was created, after we used this fork. So the child process now comes here to start from here now. It checks what was returned. Is it -1? No, because the program did not fail, right? If the fork system call failed, then it's going to come here. Or the parent process would have done that already. Sorry, the parent process would have done that. So it comes here. So if this fork system call was successful, this child the fork is going to return 0 to the child process. Remember that what that was said, that was mentioned in the man page. It's going to return 0 to the child process. So what we are going to do now is that in that child process now, we want to execute the command that the user typed on the terminal. All right, and what we are going to use to execute that command is this exec function, so that after it executes that command, it's going to leave that child process and then return to the parent process to continue running the program. You get? So let me see the man page for the exec function. Exec VE. So it says, so we have the path name. We have the path name. We have the array of strings, and then we have the environment variable. All right. So the path name is going to be the path to the command. For example, look at this. Look at what was used here. So this shows us the path. All right. The command that we want that this program is trying to execute is ls, and we know that ls, what it does is to list the files or directories in a particular directory. So this slash bin slash is just the path to that particular command. All right. So what we're going to do now is this man page now. The first argument here takes in the path. This second argument takes in the array of strings, and then this one takes in the environment variable. So I'm going to then let's check the return type too. The return type for this exec v function. Let's see what it does. So it says on success, exec v does not return. All right. If it is successful, it does not return anything. But if it is not successful, it returns -1. So what I did was I just used one command, one line to take as into. Let me just write it. What I did was this. I said if exec ve, then I put in all those arguments. I think there's something I'm missing. Yes, this. So now, this standard in is going to fetch in the command that user is imputing, and then I'm storing it in this string, right? So what I did was to store the value of that string as the first argument here. All right. So what I did was I did this argv 0, and then so the command that the user typed in, I put it as the first argument. All right, to this array of strings. So this null now will be changed to whatever argument or whatever command the user gave. So the first argument here is the path, and that path is that argv 0. And then the second argument is let me just get it. Second argument is the array of string, which is this variable itself. So I include that there. And then the last argument is the environment variable, which is env. So that was passed into the function. All right. So what I did was that if after it has executed this function, then it checks if what was returned is -1. So if what was returned is -1, right? So it runs the function. This line is doing like two things at the same time. So it's running this command, and then it's checking for the return value at the same time. So if what was returned is -1, it means the exec function failed. What I'm going to do is I'm going to display an error message. If you go back to your project, it says something. It says if an executable cannot be found, print an error message and display the prompt again. So they gave us an example here, and it's something like this one now. For this particular task, we are only working on a single command, right? So it takes in, this, for example, now this one now, it takes in a command and an argument. So it's going to this is an error message that I'm supposed to display, because I'm only taking care of one command without an argument. So if the exec function cannot execute, this command with argument, this is the error message I wanted to display. It's going to display, this executable file name that I used here, and then with no such file or directory. So if it fails, what I want you to do is to print. So I need to get this whatever I used here, and the way to do that is through the argument vector. That was why I had to pass it inside here. And so remember the argument vector, the zeroth index will give us whatever was used here. All right. So then I'm to do this. Let me get that command again. No such file or directory. No such file or directory. And with this. So I'm to use this 0. All right. So now what happens is that when the child process comes here, and then the fork program is successful, then it runs this program. All right. Now, if it runs this program and is successful, we are going to have something like this. Let's say, imagine the user, typing this. All right. It's going to display the list of files in that directory. But if it is not successful, if this function returns -1, then this is going to be printed. Okay. This is going to be printed. Right. So remember that the exec function, it does not return back to the origin it does not return back to continue whatever was running. All right. So if this function executes, all right, after it finishes executing, whether it failed or not, it's going to leave that child process. And immediately leave that child process, it's going to come back to the parent process. So this parent that was waiting already now continues. And then it continues with this while loop again, and then it prints this prompt again. Hello?
Yes. We are here with you.
Someone was saying something.
I'm not sure.
Right.
I didn't hear anybody.
Okay. So the parent process comes back, and then it goes back to continue to print this prompt again. So let me see. I think this is all for that task 1. Let me run it and see. So pardon me if I'm not really explaining it like where I'm not so good like that, but just trying to explain it as best as I can. So let me try to run it and see. Okay, there's an error. Where is this coming from? Oh, sorry. I'm in the wrong directory. Okay. All right, so let me see what's happening here. Okay. Let me see deadline. What's okay, size T. I used int instead of. Sorry. Here is it again. Then right. So I used the wrong variable type. So txt. Okay. What else again? And the width, implicit declaration of width. Yes, width defined. Okay, sys width. So I have to include the header file for that. That is sys width .h. So I don't know why my VS Code refuses to read this, but the program still runs. It still ran when I did mine. But so let's just check and see. Okay. But again, okay, the shell. I need to return 0 here. Okay, I think it should work now. Let's see. Okay. So let me try to follow what was here. So the program compiled. So for me, I'm using this name. So let's see. So you can see it has given me a prompt, and then it's expecting me to type in a command. So if I type in bin/ls, okay, that means there's a mistake somewhere. It's supposed to give me the command. I'm supposed to execute this command. Let me try something again. Okay. So please join me and look at the code. Let's see. Like there's something I'm missing. So if the argument is 1, if the argument count is 1, it should execute that argument, and then it comes here, right? So I initialize my string to null. So let me just come. So it prints the prompt, and then after printing the prompt, I try to get the command that the user types, right? And then I store it in this string, and then I check if what was returned is -1 if this function fails. So if it fails, I'm to free this string and then exit the function. But if it does not fail, I come here and then I remove the new line character, all right, that is in this string. So I check. So while the value, all right, while the value at each index is not null, let it come into. Okay, I did not increase I. Sorry, I is meant to be incremented. So let me try it again and see. Okay, so bin/ls. So you can see it works. So it executes this command. It prints all the data inside this file directory, and then the prompt still comes up again. So if I try to print in ls alone, let's see if it gives us the right to. Yeah, so you can see that no such file or directory. That is just what we have here. All right. So normally it's supposed to actually work for the normal shell. ls is supposed to work, but we have not yet come to that particular task. So, but for this task, what we are doing is we are getting the path to this particular command. The command is ls. So this is the path to the command. And then this prompt, my shell prompts me to type in this command, and then after I type in the command, if that command is found, if that command is present in, I think, the environment variable or something, so it executes that command, right? But if it's not found, then it gives me this. So if I try something like, let's say bin/bright, if bright is not in my environment variable, it's going to give me no such file found. So you can see there is no such command as bright in my environment variable. Oh, I can't remember if it's environment variable, but if this command is not found, right, if it's not a valid command, it's not going to print. But because ls is a valid command, it's going to print. And then let's also check if it takes care of, if it gives us the right output for command with arguments. So let's say we have this. So it's giving us the right result. All right. So you can see that every time it takes in a command and then it prints out the output, this cease for this prompt comes up again. That is because we have that infinite loop. All right. So then let's try this or this other one. So let's try Control C to come out of this my prompt. So that works. And then let's try this other one. I'm not using shell. I'm using some different name. So mine is this. So let's see if it gives us. All right. So now this is one of the things I was having issues with. Mine, it printed out, it executed the command. Okay, so first of all, what this is doing is that I'm echoing this command, all right, and I'm piping it into this into this executable file. So what is happening is that this executable file is going to be run, and then whatever was echoed is going to be, it's just like me trying to execute this same function. But the thing is that I'm not executing it the same way I'm doing it here. This first one I did is called the interactive mode, where, after I run this executable, then the user will get to type in the command as you want. But for this one is called the non-interactive mode. You can just pass in the command directly to your executable file and then it runs. You don't need to be doing all those, getting a prompt again. So for me, what I noticed is that this one, it only gave out one, but mine gave out two. So I found a command, all right, it's called is a TTY. This command here is it again, is a TTY. So what I understand about that command is that let me man it. Man is a TTY. Okay, so you say it tests whether a file descriptor refers to a terminal. The TTY function tests whether file descriptor is an open file descriptor referring to a terminal and blah blah blah. So what I understand about this ECTTY is that it checks if what I'm okay, this was how I used it. I can't really explain it, but this was how I used it. I used the ECTTY to check if I'm going to be receiving a command from the standard in. All right. Now, if I'm going to be receiving a command from the standard in, this C font should be printed. But if I'm not going to be receiving a command from the standard in, then this C font is not to be printed, meaning that this is a TTY will function for interactive mode. All right, this C is will function for interactive mode, but for non-interactive mode, we're not going to have this. So when I did that, let me run the command so that you see what happens. Let me compile it. So if I try to run this program in non-interactive mode, this is what it gives me. It doesn't give me that CS4 prompt at the end here. It doesn't give that CS4 prompt at the end here. So that is just the only difference between my own and this one. When I ran this command in non-interactive mode. But I think, so what I led you that way was because that is how the shell works normally. It's not supposed to give us this thing. So maybe later in the project, it's going to, we are going to be asked to take care of that. So that's why I left it. So if we still do that, if we try to run the program in interactive mode, it's still going to be working fine. So it still works fine. So that was how I did my task 1. So I don't know if there's any question.
Yes. Hello, Bright.
Yes.
Yes. My question is, can you actually go back and explain I think it's shell.c on your VS Code?
Okay.
Yeah. Yeah. Can you explain to me the code inside the main
Okay.
function?
So do you know this parameter, this argument
Yeah,
inside
I know
this
those ones.
main? Okay. Yeah. So what I did was that if the argument count is 1, now this is what is good. This is an argument. This is an argument. This is an argument. So here the argument count is just 1. So I said if it's just 1, yeah, then it should execute this function. It should run this function. And this function now is taking in the argument vector and it's taking in the environment variable. All right. So when it comes here, it goes to this prompt and then it runs all of this. You get?
I get.
Yes. So that's what I did.
What if the count is not 1? It's more than 1.
So that one I've not yet done it because they didn't tell us what to do for that. I don't know what to do in that area for now. But I mean, we can also discuss this if anyone has an idea of what to do if the count is not 1.
Since they didn't specify, I would suggest that we move forward.
Okay, so you have any other question? Okay, so let me move to task 2. So in task 2 now we have to handle command line arguments, meaning that this one now that showed us no such file or directory, in this task 2 now it should work. All right. Now normally, let's see what it gives us normally in the normal shell that we have. If we type in bin/bin/ls and we put L, so we can see that it displays the list of files and then it gives us more details about those files. So this is what we want our program to give us when we run it, when we run the command with this argument. So now we are going to go back to the prompt file. So again, it prompts us for an input, all right? And then we store the command. We store that input now in this string, and then all and. So we remove the new line character, and then we come here. Now, at this point, what I used here initially was no. But now it's possible that the command that user will be typing will take in more than just 2 arguments, and the array of strings must always end with a null. If you read the man page for this exec function, it tells us that the array of strings, this second argument here, it must end with the last element there must be a null to tell the exec function that it has come to the end of that array of strings. So since our user now can type in more than one element and more than one command, more than one argument for that command, it means this one now will not be sufficient. This one now is just telling me that I can only take one command without argument because null must be there, right? So what I did was I defined what's it called again? A macro, all right? A macro for the maximum number of commands. I just used my own because it was not stated here. So maybe somewhere in the program it was stated, but I just used my own. So the maximum number of command, I used maximum number of command, and I used let's just say 10, all right? So that I can use this macro now to initialize, to declare this variable and tell it the maximum number of commands, the maximum number of elements in that array it's going to take. So I have to delete this one, and then I'm going to put this here. right? So meaning that my array of string, the array of string is going to take as many as 10 possible strings in that array, all right? So now when we come to this place, so the command is stored here, and then it comes here, the new line character is removed. And so now we have to, if we have something like this bin/ls, this now is the command, this is the argument. So we have to find a way to separate the command from the argument. That is where the string and the string talk function comes in. So if a man string talk, it says that, so the string talk function breaks a string into a sequence of 0 or more non-empty tokens. On the first call to string token to string talk, the string to be passed should be specified in this argument here, and then each subsequent call should pass the same string. Now, what that means is that, so this function basically it will take in this command here as a whole string, and then break it down into what is called tokens. The token is just this one now is a token, this one now is a token, and then it uses what is called a delimiter. A delimiter is just what that function uses to separate one token from another token. So if you look at this function now, this command now, what is separating this first token now from the second token is a space, meaning that the delimiter that we're going to use is space. You get, right? So you can see this string talk function, it takes in the string. The string will be this argument now will be this string that stores the command that used as typing, and then this second argument now will be the delimiter, which will be our space. All right. So now when we get here, so what we have to do now is, so it says something here that it says on the first call to string token, the string to be passed should be specified in string. So, and then it says again that in each subsequent call that should be passed to the same string, this argument now will be set to null. So this is how it's going to work. So when we first call, I'm going to remove this, and then when we first try to separate, and when we first try to call that function, that string talk function, okay, I have to include the header file for string. That is string.h. All right. That's where it's defined, where it's declared. So string talk. All right. So remember, the first argument there is the string, and then the second argument there is the delimiter. All right. So when this function runs, the first thing that it's going to return is this first. Let's say, imagine this was what was passed as that string. All right. So the first thing that will be returned is this first token. Now, this first token is what we are going to is going to be stored in the first index of that array of string. Remember that this is taking the path, and then this is taking the array of strings variable, meaning that the other argument now is going to be the exec function now is going to run the command, and then it's going to fetch the argument of that command from this array of strings, which is here. So this one now will take in the other path, which is this bin. You take in this first token, right, which is the path to this particular command, and it's going to be stored in the first index of that array of strings variable. Now we are still going to we still need to fetch other tokens. All right. So how we are going to do it is to use the while loop and say that while okay, there's something else I need to do. I will need to, because I'm going to be checking each index in that array of string. Now let me show something here. The string token. Let's see what let's see the return value and see what it says. It says that the string talk function returns a pointer to the next token or null if there are no more tokens. All right. So meaning that if it returns this token, all right, it stores it in whatever is holding, whatever is going to hold it, and then it's going to move again to the next token, all right, and then it's going to store that token, and then if it gets to the end of this command and it finds out that there is no more token to be stored, it's going to return a null, all right. So we're going to check. We are going to use that to check now. So I have to declare a variable to move from one index to another in that array of string. So I'm going to let me use J. So let me add J here. And then there was something I learned. I learned it like hard. And that was not to initialize my J to 0 outside of this while loop. I will explain that later. So I initialize my J to 0 here. So I can choose to put, just change 0 to J, or I can just leave it at 0. Either way, it's still going to be 0. So I'm going to check, all right?
Excuse me, Bright.
Yes.
Can you at least zoom your screen? Can you try zooming?
Okay, that's wide enough. How do I zoom this thing now?
From the Chrome.
No, this is VS Code.
That is VS Code.
Do Control plus.
Okay. Is it better now?
Yeah, it's good. Yeah, there. That is good.
All right, thank you. All right, so I'm going to check each index. All right. Remember that if the string talk gets to the last token, if it finds out that there's no more token, it's going to return null. So if it returns null, I'm going to check as long as what is returned is not null. All right, I can put this as this, while this is not equal to null. All right, but for me, I don't like writing too much lines, too much code, so I just put it as this because it still does the same. It still serves the same purpose. So while the value at this particular index is not equal to null, so what is it supposed to do? Now, remember it says something in the man page that in each subsequent call, all right, in each subsequent call of this string talk function, that should in each subsequent call that should pass the same string, this string should be set to null. Now, what that means is that if it comes here now, I'm going to call this string. I'm going to do this v I equal to, I'm going to call this function again, that string talk function. All right, and then what will be here now will no longer be this string, it will be null, and then I will still have my delimiter. Now, why this is set to null is to tell this function that it should continue from where it stopped. All right, it started with this string. This null tells you to continue using that string. All right, so when it runs when the function runs at this first instance, it stores the command, right? So when it comes here now, it's going to continue from where it stopped, all right? So I'm using I, not it's supposed to be J, all right? So at this point, J is 0, and let me just use J here so that I will not make things confusing. So at this point, J is 0, meaning that the index at index 0, we are going to store the command, the first token. All right. Now, when we get into this function, the next token that should be stored shouldn't be, J is still 0. So it means we have to increase J. So there are different ways you can do it. So you can come here and say J plus plus, and then so meaning that J now is equal to 1. So that at index 1, the next token will be stored there. At index 0, the first token was stored. At index 1, the next token will be stored there. And then it continues like that. Or you can do it this way. What I did was to just, because I was trying to reduce the number of lines I had. So I just did this inside this square brackets so that it's running it at the same time. So it's increasing J. J now becomes 1, and then it stores whatever values return inside of this first, inside of the at that index position. So that I will not have to write, G. I will just have just one line. So I like to reduce the number of lines of code I have. So you can also do it this way. So this still works, all right? So while the value at this index is not equal to null, it should be storing the remaining tokens in the subsequent index, all right? So that's what it does. And what again? Then remember, for this exec function to work, all right? For it to work, it means this argument, this array of strings has to end with a null to tell this exec function that it has reached the end of whatever is found in that array of strings. You get? So meaning that when this function now, when the string talk function reads the last token, and then it finds out that there is no more token, it's going to store the last it's going to store in the last index null. So meaning that when the while function comes here and it checks again, is the value at that particular index null? It's not going to enter this while loop, so it's going to come out. All right. So now what we are going to do is that we are going to set the value at that particular index. Is there need to set it? It's already null. So what I did was to set it manually. But let me just try it and see if it's going to work. So this was going to happen. And then I said something. Why I put my J, why I initialized G as 0 here was, initially I initialized my G as 0 outside of this while loop. And this is what happens. When this prompts me and then all these functions start running, and then my J now it runs here. If this J now increases, right, and then it does whatever it wants to do. If it wants to go back again to this while loop, the J will still be as in, it will still be what I put in. Okay, imagine now the J after it has reached this place, the J is like, let's say 2. So when it comes back to this while loop to run, maybe I want to execute another command again, and then the program prompts me for a command. If it gets to this point, J is no longer 0, and it's no longer what it's not starting from the beginning. Imagine I don't have this J here. Imagine I declared it outside of this while loop. It means the J is still going to is going to continue from where it stopped, right? But if my program is coming to give me to prompt me for a command, it means it's starting. Everything is supposed to start afresh. So that was why I had to declare my J inside of this while loop, so that after it runs the first command, if it's coming back again to prompt me for another command, everything is going to start from the beginning again. Right? I'm going to fetch the command, break it into tokens, store the first token inside of the first index. All right, and then it goes like that. So that was something I learned in a hard way. So I think, what else again? So I stored the first token inside of the first index of this variable, and then I check if it has gotten to the last token. All right. Then okay. So let me run this and see. Hope I'm not missing anything again. Let me run this and see. Okay. Let me see. Let's check for just a command and see if it still works. Okay, it still works. Then let's check for a command with an argument. Right. So you can see that it gave us this. This is what we were expecting. It gave us this. So if I want to, let's take in more arguments. In -ls -l and slash tmp. So it still works. So let me check bin /ls -la to display all the files, including the hidden files. So you can see that it still works. So let me come out and see if it works like that in normal shell. So let's compare what we have. So you can see that it works the same way the normal shell works. So that is just how it is for tax 2. So we just modified this one. We modified this one. I declared the macro to hold the maximum number of commands it will take. So the maximum number of elements this array of strings will take. And then what else did I tweak? This place. This string talk to break that command, to break the string into its command and then its argument. And then that was it. So when it comes to this exec function, this one now runs that first. It runs the path. It runs the path to the command. For example, it runs this one, and then from here, this exec function is going to continue running with the arguments of that particular command. So if it's not found, it's going to print no such file directly. So let's see if that still works. Just to be sure everything is still. Sorry. Bin slash. Let me try it right. Okay, everything still works. So that was just how I did my own. So I don't know if there's any question.
Yeah, sorry. I just want to. Yes, sir. Can you hear me?
Yes, I can hear you.
Because I want to be clarified on this very part when you said you're declaring your J inside the while loop. Is it inside or within your program?
It's within the program, but inside of the while loop. All right. This is the program itself. But this is the while.
When you say inside of the while loop, yeah, the J is declared on top of
it's
a function. So I don't think it's inside.
It was declared outside of the while loop, but initialized within the while loop. This is where I initialized it. Yes. This is where I declared it. This is where I initialized it.
Within the program.
I
guess not the while loop.
Huh?
I guess it's within the program, not the while loop. If you say the while loop, that means it should reside inside the while loop, not on top. So that should be within the program, I guess.
The program is all of this. Everything we are seeing, everything on this we are seeing on the screen. All of this, that is the program itself. The program is just a collection of instructions. So all these things you are seeing, they are instructions. The computer is reading the instruction one by one. So the program is a collection of instructions. So within this program now, there is the while loop. And so instead of this while loop, I initialize the G variable. So let me.
Yeah, I've seen it. Thank you. I've seen it.
Let me initialize the G variable outside of this while loop, and let's see what happens. So if I try to compile it, and then run it. So let me that one now is for command with arguments. So ls, let's use L. It still works. Okay, yes. So it worked for the first one. Now let me try again. And you see what happens. So you can see it doesn't give me the same. But this is not what I was getting. Let me try it again and see what happens. Sometimes these things can just be funny. Wow, this is not what I was getting. Mine, it was giving me.
I think you're getting because you have J equal to 0 in two places. Check.
Two places. I removed the other one. It was here before. I removed it. And I put it outside of the while loop. So it's giving me a different result of what I got when I was doing mine. Huh? Let me check the other one and see. The one for non-interactive mode. Let's see. Okay, this one still works. Let me try this. Okay, let's try it again. Okay, this one still works fine. So that was basically that was just there was something that my mind was misbehaving when I declared the outside of the while loop. But I think it's safe because if you look at the logic, if a new prompt is given, everything should start again from the beginning. So I think it's safe for the J to be initialized inside of the while loop. So that was how I did my task 1 and task 2. Any other question? So I don't know. Does anybody have a better logic, like a better way of doing this? This is just the logic I developed. So I don't know if there's maybe a better logic to doing it. You can rub our minds together and do it. If anybody has done it already.
Okay. Hi, Bright.
Yeah. Hello, David.
Okay, I must say you have done a very good job here. Yeah, I'm here with you. I said I must say you have done a very good job today.
Thank you.
Okay, and and we appreciate you a lot for the time. It's not easy to actually study and then come to also share with others. So thank you very much.
Thank you very much.
Okay. All right. So asking if there are other ways we could implement this. Everybody might have their ideas, but for you sharing this, I believe it has given us insight on what we should do. Like me, while you were doing it, I was just like, damn, I should have done this. I should have done that. Okay, so definitely, before I sleep, I'm going back to my program.
All right. Thank you very much.
I've texted my partner, so definitely there are some things I will change, and there's some adjustments I will make. So I appreciate you a lot for your time here. Okay.
Thank you very much for the opportunity too.
Okay.
Thanks.
So I had a good time to actually. Then we don't have any questions now. So please, if you have any questions, even now or after now, you can. Okay, since we're in the period of the project, you can ask your question in the main group and tag either Bright here. After now, I'm going to tag Bright to a post so you can see his number in case you want to ask me a question on tax 1 and tax 2. Then you are free to do that. Okay, so Bright, I believe if somebody has a question here, Richard. Richard, go on.
Okay.
Okay, I wanted to.
Oh, Richard, that's my partner.
Oh, really? That's nice.
Richard. Yes.
This thing is over 40 lines. This problem with Betty and Co.
Yeah. Thank you.
This STRTK, the way I put it in the one I shifted it into another function that is outside this. You just need to just call that function. And once you call it, you should be returning the array of strings. So you now need to pass the array of strings, that's all. So that you will not get rid of all those aspects
right?
of
In the one I did, everything was so much shorter. So this is one I did myself. Even the one to remove that new line character, I just used one line to do that. Then I used the function in another outside of that prompt function. So this one took care of the new line. So at the end of the day, this is what I have for. Although Now, currently, I'm working on task 3, so that's why some things are still a little bit messy. But later on, how to reduce it. So this one was long. It was long just to explain like each step.
Okay. Okay, I get it. All right.
Okay, good. Okay, so I believe with everybody seeing this, you can actually take this code here and go back and study it, and maybe you take your time and reformat it and shorten the parts you don't want. And of course, you have something good at the end. But this is actually good. It's not everybody who would sit down and write all this. So I'm very happy actually to see you doing this. It's nice. It's motivating.
Thank you.
Brian, thank you very much. Yeah.
Thank you, David.
Thank you. So, okay. So for anybody, is getting late already. For those who are staying outside our time zone too, so we'll allow them to go and rest. So if you have any questions, please, after now, I'm going to tag Bright in the group. In case you have a question, you can tag him, tag me, or tag any other person too. And of course, we are a team. We will definitely reply to you. Okay. So please, if you text me and I don't reply you instantly, maybe in my DM, please, definitely, I will reply you eventually. You know, I also have work to attend to, and I have ALX to also attend to. Like today, I had so many people complaining and getting angry that I was not replying to their messages. Today, I had a long day at work. Please, I apologize for all those. So I thank everybody for being out here today, and definitely we look forward to having another meeting like this tomorrow with another of our own too. Okay, so I appreciate everybody, please, and thank you. Till tomorrow again we meet. So we can unmute our mics now and appreciate everybody for being out and tell ourselves good night.
All right, thank you, everyone. Thank you, David.
Good night, everyone.
Thank you.
Good night,
Wow.
Good night. Good night. Thank you.
Good night, everyone.
Good night. Good night. So, good night. And Blessing has been here all this while. Blessing, you entered from the back door. She has left the meeting already.
Good night. Good night.
Okay.
Thank you.
Good night,
everyone.
Good night. Good night. Okay. All right. Bye. Bye, everybody.